Signature Solar is excited to introduce a new brand to our lineup, Pytes. We're now carrying the V5 lithium iron phosphate 51.2 volt server rack battery with additional components such as battery brackets for stacking and an outdoor cabinet that transforms your indoor batteries into an outdoor setup. Pytes is redefining scalability and flexibility in energy storage, and we're thrilled to show you what it can do.
Hey everyone, I'm Kelly with Signature Solar, and today we're going to take a close look at the Pytes V5 battery. I'll give you an overview of its features, show you what's included in the box, and then put it through a series of tests to see how it performs. We'll demonstrate how it connects with popular inverters for seamless closed-loop communication, run a discharge test, and check its low-temperature charging capability with its integrated heating pads. Let's dive in. First, let's see what comes in the box with the Pytes V5. Inside, you'll find an RJ45 communication cable which lets you connect multiple batteries in parallel. You'll also get a grounding wire for safety, 2 copper bus bars for battery-to-battery connections, and of course a user manual to guide you through the setup and operation. These accessories make it easy to scale up your setup with multiple batteries, and the included connections help ensure secure and effective operation right out of the box. The Pytes V5 battery offers 5.12 kilowatt hours of usable energy with a 100 amp hour capacity, making it a versatile choice for anyone needing reliable and scalable energy storage. Designed for compatibility with popular systems like EG4, Lux Power, Victron, Growatt, and Schneider, this battery works seamlessly for off-grid backup or grid-tied setups. The V5 is built with Tier 1 EV LFP Grade A prismatic cells, known for their longevity and resilience under frequent cycling. These high-quality cells are engineered to withstand rigorous use, making them ideal for demanding energy storage needs. Pytes has also equipped the V5 with a self-designed battery management system, which includes multiple layers of protection to ensure safety and long-term reliability. Each battery undergoes a 48-hour aging test before leaving the production line, resulting in a remarkably low failure rate of under 0.3%, with most issues easily resolved in the field if they arise. In addition to its build quality, the V5 meets important safety and quality standards, including UL 9540, UL 9540A, UL 1973, and CE certifications. It's backed by a 10-year warranty, providing over 6,000 cycles at 90% depth of discharge and a round-trip efficiency of over 95%. As for specs, the V5 has a nominal voltage of 51.2 volts, weighs approximately 97 pounds, and supports a continuous charge-discharge rate of 75 amps with a maximum of 100 amps and peak discharge rates of up to 180 amps for short bursts. With the optional Wi-Fi dongle that you put right here, users gain access to remote monitoring, alarm notifications, and troubleshooting through the SolarMan platform, making management simple and accessible. The V5 scalability is impressive as well. Up to 16 batteries can be stacked per group, totaling 81.92 kilowatt hours, and with a hub, 6 groups can be linked for a massive 491.52 kilowatt hours, almost 500,000 watt hours of storage. Additionally, it's designed to perform in extreme temperatures, operating between -4 degrees Fahrenheit and 122 degrees Fahrenheit, with an integrated heating pad to keep the battery safe and functional, even in colder environments. Let's take a look at the front panel of the V5 battery. You'll see the main starter switch and a soft start switch, which we'll use when powering up in multiple battery setups especially. There's also a dip switch for setting up communication protocols, an alarm indicator, and a running light to show the battery's operational status. Below that, we have the SOC indicator, which shows the battery's state of charge, and communication ports for CAN and RS-485 connections. For added versatility, there's a dry contact port and an IoT port, enabling remote firmware updates and data collection for diagnostics, again through the SolarMan platform. Lastly, you'll see the negative and positive power terminals, each with easy access push-button doors and top and bottom knockouts to accommodate your battery cables. Let's start by testing the Pytes V5 battery's compatibility and closed-loop communication with the Victron Multiplus II setup, which is a bit more involved due to Victron's modular nature. For this setup, we'll be using the Victron Multiplus II inverter, a Servo S GX, and a Victron Energy GX Touch 50 screen for monitoring and configuration. It's important to check that the communication cable has the correct pinouts before beginning, as the setup is precise. For Victron systems, the communication protocol requires that all dip switches are set to the down position. Always refer to the Pytes Quick Start Guide at pytesusa.com/Quick Start Guide to verify the correct dip switch settings and pinout details specific to your inverter. We'll put this link in the description. With everything set up, we'll follow the power-up sequence. First, we turn on the main power switch on the battery. Then we'll hold the soft start switch on the master battery until we see the run light blink. Finally, we can power on the Victron inverter. Once the Victron system is up and running, we may need to adjust some settings on the GX touchscreen to confirm the system is communicating properly. If everything's connected correctly, we should see the state of charge percent displayed on the screen. The SOC percentage is showing as expected, indicating a successful connection with the Victron setup. This compatibility highlights the flexibility of the V5, which can connect seamlessly with many inverter brands. Now, let's move on to testing with the EG4 6000 XP. As we connect the V5 battery to the EG4 6000 XP inverter, you may notice this is a very straightforward setup. First, we'll connect the battery cables to the battery using the protected terminals. Just a push of the button releases the terminal doors. There are knockouts on both the top and bottom to accommodate the cable routing as needed. I've already removed my knockouts so the cables lay flat. We'll tighten the cables on both the battery and inverter terminals, making sure to double check polarity for safety. For the EG4 6000 XP, we're using CAN communication. We'll plug the communication cable into the CAN port on the battery and the COM port on the inverter. Next, we'll adjust the dip switches for the communication protocol. For EG4 or Lux Power inverters, switches 3 and 4 should be up, with all others down. With this setup complete, we're ready to power on the system. For powering up, the order is always very important, as stated with turning on the Victron. First, we'll flip the main power switch on the battery. If you're using multiple batteries, turn on each switch, then hold on the soft start switch on the master battery for 1 to 2 seconds until the SOC lights on all batteries show running. Once all batteries are on, we can power up the inverter. With the inverter on, if you don't immediately see SOC percentage, you may need to set up the brand of battery to read correctly. For us, everything displays correctly here, confirming a good connection with the EG4 6000 XP. A quick note, Pytes is currently working with EG4 to obtain UL 9540 certification, which they're really close to securing. This will provide an additional level of reliability for our customers. Now let's run a discharge test to measure how the V5 handles a continuous load. We've already connected the V5 battery to the EG4 6000 XP, so we went ahead and connected a panel box with an outlet so that we could run this load test. We have 7 heat lamps, each with 250 watt bulbs to run this load test. We're gonna go ahead and turn the battery on and see how the inverter is reading how much this load is. This will give us an indication of an estimation of how long it should take to discharge this battery. We're also making sure to charge this battery all the way up to 100% before we begin to run our test for a discharge. So let's go ahead and turn on the battery. Oh, it's already on. We're gonna go ahead and leave that on. That's right, because we're charging the battery. We'll turn on our battery breaker. Turn on our inverter. And we can see right now our battery's at 94%, so we'll make sure that this charges all the way up to 100%. We'll turn on our EPS output, and then we'll turn on our load. Okay, so all 7 lights are currently on, and we're currently reading 1.84, 1.85 kilowatts. Let's see how it settles down. You can hear the inverter ramping up just a little bit. Okay, it's settling in at about 1.84 kilowatts or 1,840 watts. So to estimate the time it's going to take to discharge this battery, we can take its capacity at 5.12 kilowatt hours. And we're going to divide that by the kilowatts that it's going to be discharging, 1.84. And it tells us it's going to take about 2.78 hours. That's about 2 hours and 45 minutes. However, that's a rough estimate and doesn't account for a few factors. First, Pytes state that the V5 has a round-trip efficiency of over 95%, meaning we might lose a small amount of energy in the process. Additionally, the battery's depth of discharge is set to 90%, so the BMS will stop the discharge slightly before reaching zero. With these factors, it will take slightly less than 2 hours and 45 minutes to fully discharge. Let's go ahead and run this test to see how long it actually takes to discharge the V5 with our current load once we fully charge it to 100%. We'll keep an eye on the time and come back once we reach the battery's limit. This test will give us a real-world measurement of how long the V5 can sustain a continuous load of 1.84 kilowatts, providing insight into its actual usable capacity under these conditions. So we have finally completed our discharge test. Our lights went off, our inverter went off, and notice there's still a slight bit of state of charge on our battery display there. I need to make a slight correction in our calculations based on the UPS settings displayed on the screen. While running these loads, the inverter was actually outputting approximately 1.73 kilowatts as indicated by the UPS reading, which I did not notice at first. However, the battery itself was delivering 1.84 kilowatts, which must have been accounting for efficiency losses in the system. If we recalculate 90% of the battery's 5.12 kilowatt hour capacity, that gives us 4.61 kilowatt hours. Dividing 4.61 by 1.84 yields an estimated runtime of about 2.5 hours. Here we see that we were able to run this load for 2 hours and 18 minutes. This load test not only gives us an estimate of how long the Pytes V5 can sustain a load at just under 2,000 watts, but it also highlights the safety features built into the battery's BMS. The Pytes BMS is designed to automatically stop discharging at 10% state of charge, ensuring a safe depth of discharge at 90% unless overridden by the inverter. As we observed, the inverter display verified that the battery's BMS shut down at 14% state of charge, a little earlier than expected. However, this still ensures that it adheres to the safety threshold, confirming that the BMS is functioning within the safety parameters established by Pytes to maintain a 90% depth of discharge, providing you with added peace of mind. Now it's time to test the V5's low temperature charging capability and the functionality of its integrated heating pads. To simulate cold weather, we're going to place this battery in this controlled freezer environment. We're looking to see if it can continue charging at low temperatures, specifically below 41 degrees Fahrenheit or 5 degrees Celsius, with the heating pads activating to keep the battery within a safe charging range. We've connected our V5 to a variable DC power supply to set charge at 5 amps, which will allow us to monitor charging stability while testing if the battery maintains charging at low temperatures. We'll also keep an eye on the clamp meter, which we will attach to one of the heating pad wires. Any current flow detected here will indicate that the heating pad has activated. When we see a reading of 0 amps, we'll know the heating pad has turned off. This will help us verify that the heating pad is automatically maintaining the internal temperature for safe charging. We're monitoring the ambient temperature with this thermometer inside the freezer, and we'll use the Pytes Wi-Fi dongle to record the battery cell's internal temperature, giving us a real-time view of when the heating pad kicks in. Ideally, we'll see the heating pad activate when the temperature dips low, ensuring the battery stays within a safe range for charging. There it is, our clamp meter is now reading current flow, indicating heating pad has activated as expected. The battery is still receiving a steady 5-ish amps from the power supply, allowing it to continue charging even as the temperature drops. This feature is essential for colder climates where freezing temperatures can degrade lithium iron phosphate cells, potentially shortening their lifespan. To protect the battery, the BMS will shut down if the cells get too cold, pausing operation until temperatures return to a safe range. As the temperature rises above 50 degrees Fahrenheit, we will see the heating pad will turn off as indicated by our clamp meter reading 0 amps. This automated heating feature is highly efficient, only engaging when necessary to maintain optimal battery temperature. For those installing batteries in extreme conditions, this level of smart control can make a big difference in performance and longevity. Let's review some of the standout features of the Pytes V5 battery. One of those is its amazing scalability. You can parallel up to 16 of these batteries in a single group. With a hub, you can expand that to 6 groups, totaling 96 batteries. That's over 491.52 kilowatt hours of storage. This makes the V5 suitable for small residential setups as well as large commercial projects where you might need a lot more power storage. If you're an installer, you'll appreciate how the V5 simplifies the setup process. The improved busbar connections and new design make wiring straightforward, reducing the clutter and potential points of failure. Compatibility is a key consideration when choosing a battery, and Pytes has you covered. The V5 communicates via RS-485 and CAN, enabling closed-loop communication with popular brands like EG4, Victron, Growatt, and many others. Closed-loop communication ensures that the entire system works seamlessly with battery and inverter constantly talking to each other to optimize performance. The setup process is easy too. Just adjust a dip switch, connect the communication cable, and you're good to go. No need for complex configurations. It's simple, efficient, and reliable. During our test, we successfully connected the V5 to a Victron and an EG4 6000 XP inverter, showing how easy it is to set up. We used the soft start feature, set the dip switches, and the battery communicated seamlessly with both inverters without any issues. Safety and reliability are at the forefront of Pytes design. The V5 is UL 1973 and UL 9540 listed, meaning it has passed rigorous third-party safety testing. Its integrated BMS ensures safe operation, protecting against overcharging, over-discharging, and temperature extremes. During our discharge test, the V5 safety features engaged as expected, showing alarms and limiting discharge when the battery reached critical load levels. The integrated heaters also performed well, activating automatically to maintain optimal battery temperature during charging in colder conditions. Unlike some other systems, the V5's heating elements are smart controlled, ensuring efficiency and only engaging when necessary. Whether you're using it for backup power or as part of an off-grid solution, you can trust that it will perform safely. The versatility of the V5 makes it ideal for a wide range of applications, from residential setups aiming to reduce utility bills to larger commercial installations that require substantial energy storage. The V5 can handle it all. Plus, although the IP20 rating makes it perfect for indoor installations, it can easily be transformed into an outdoor installation when combined with the Pytes outdoor cabinet. If you're looking for a reliable, scalable, and intelligent battery solution, the Pytes V5 is worth serious consideration. After going through these tests, I can confidently say the V5 stands out in terms of flexibility, efficiency, and ease of use. I'm Kelly with Signature Solar, empowering you to own your own power. We'll see you next time.
For more details, find this battery and more at signaturesolar.com. Also, subscribe to our channel and follow us on Facebook at Signature Solar US for all the latest products and solutions.